Hi guys, I'm live. How you guys doing? I'm going to do some walk rant. I want to do a walk rant about math for a while now. Except I'm doing it now, which is not very long ago, because now is very close to now. I studied Fourier transforms, complex variables, otherwise known as complex analysis at Harvard College. Fourier transforms are the basis of systems engineering, which is how which is the basis of the design of everything. That's either from mechanical to electrical to electronic. Not the software, not the programming geek, but the hardware is all built using systems engineering, whether it's a plane, a computer, or a phone. And I was good at it, and I want to rant about it a little bit. The whole basis of systems engineering is Euler's formula, really. If all you had was Euler's formula, you could derive everything else about systems engineering. At least I just said that. Euler's formula is e to the I theta equals cosine theta plus I sine theta. It's a way of relating the rectangular coordinates of points on the complex coordinate plane to polar coordinates of points on the complex coordinate plane. And just think here for a second. It's also a way of relating, and it's the only equation I know of that does this, at least the most general one. It relates exponential functions to trigonomical functions. In other words, it's got exponential, or e, on one side. That's exponential functions. And then it's got cosine and sine on the right side of the equation, which is a trigonomic functions. And that's very interesting, that exponentials and sines and cosines are relatable. And one way of looking at this is that if you have a real exponential function, such as y equals e to the x, it's not periodic. It just increases all the way from negative infinity, x equals negative infinity, to x equals positive infinity. It's not linear, but it's a curve that is not periodic, meaning it doesn't repeat itself over as it goes from negative infinity to positive infinity on the x-axis. But trigonomic functions are periodic because they denote motion around a circle. And motion in the circle is periodic because as you go around the circle, if the x-axis is the cosine and the y-axis is the sine, then the sines and cosines change in a periodic fashion as you go around the circle with a point. They change along the way as long as it keeps the radius, that is the distance from the origin of the point, constant, which makes it a circle. And then all you do to make it always formula-wise is make the y-axis imaginary, and the x-axis keep that real. So as you go counterclockwise, if you start at an angle of theta equals 0, which is basically two lines on the x-axis, and then go counterclockwise with one of the lines around and around, the points on that circle, all of the same radius, hence it's a circle, are described by e to the I theta equals cosine theta plus I sine theta. That is the equation of circular motion in the complex coordinate plane. And the complex coordinate plane, of course, is a plane, not an airplane, but a flat surface. But it's two-dimensional because the x-axis is real and the y-axis is imaginary, and any point is that whatever x-coordinate is the x value, and is the real value, and whatever y value you're at the point is the imaginary value, and together a real number plus an imaginary number is a complex number, and hence complex analysis or complex variables. And it actually derived this formula on a live once about 6 months ago. Had never done it before. I did it live for the first time in front of you guys, so I think that was cool. You use Taylor series. You have an expression for infinite series expression for cosine x, an infinite series expression for sine x, and an infinite series expression for e to the x, and then you plug in the right numbers and figure out, oh yeah, e to the I theta equals cosine theta plus I sine theta. It all comes from infinite series or Taylor series. Do the work. You just figure it out. If you go around the circle, when your point's on the x-axis, the cosine of theta is theta 0. So cosine of 0 is 1. So you have your x equals 1. But sine 0 is 0. So the y value is 0. So you're just at 1 on the x-axis, and then as the cosine goes down from 1 to 0, then the sine ascends from 0 to 1, and that's the first upper right hand quadrant of the angular movement, starting on theta is equals 0 with 2 lines on the x-axis. So yeah, that's cool. I like it. I like math. And the thing is, there's several constants in math that are important, and with these constants, you can do just about anything else. First of all, there's pi, Greek letter, which is the ratio of the circumference of a circle to its diameter. There's e, just the number e, lowercase. That is it is the amount of interest you can get. It's the amount of money you can earn from $1 being compounded once, compounded with 100% interest. Love you. It's the amount of money that you get if you start with $1 compounded at 100% interest. So every time you compound it, you get twice what you started with. So let's say if I have the dollar in starting at 0, I have the dollar in, and then I wait a year. Then after a year, I would have $2 because the interest is 100%. 100% of 1 is 1, and 1 plus 1 is 2. So at the end of a year, let's say it's yearly annual, or but every time you compound it, it gets taken. It gets that value. So, So after a year, you'd have $2. But that's the worst thing you can do for it, because you only compounded it once during the year. If you compound it after 6 months, then you get whatever it is at 6 months gets doubled, and whatever you have after a year of that gets doubled, and you have more than 2. You have maybe 2.1 or something. If you compound it every month, then after every month, the more often you compound it within the year, the more money you end up making at the end of the year. And if you compound it infinitely many times in the year, meaning that you're compounding it every single second or every single less than a second, you compound it constantly, you get a number that's called E, which is 2.718281828, and so forth. It's a very important constant. It's the amount of money you could get if you had a yearly interest of 100%, starting with $1 and compounded infinitely, just infinitely many times. At least the limit approaches that. It's not so much that you reach that, but the limit as x to the n to the quantity to the 1 over n, as n approaches infinity is, no, let's do that again. I think it's like this. It's like E equals the limit as x as n approaches infinity of the quantity 1 plus 1 over n, the quantity to the nth power. That describes, as n approaches infinity, that number. So as n approaches infinity of the quantity 1 plus 1 over n, the quantity to the nth power is E. And that's the amount of money you would get if you compounded it constantly, as much as you possibly could, starting with $1 at 100% interest, and what you would get at the end of the year, which is 2.71828. You actually would be $2.71. But that number is actually E. And then there's I. I is very important. I is the square root of -1. It's a number such that if you square it, you get a negative number, namely -1. But you can't. There's no such number, so we call it I for imaginary, lowercase I. Square root of -1 doesn't really exist, but we just make it up. And then when you add, and then if you add any number that's a multiple of I to any number that's a real number, you get a complex number. It's got a real part and imaginary part. Sometimes the complex coordinate plane is sometimes called the Z plane, because sometimes Z equals X plus IY. That's a good way of denoting complex numbers too. Z is a complex number with the real part X and the Y and the imaginary part Y. Hence, Z equals X plus IY. Complex conjugate of Z is X minus IY. It's the same number, but with the imaginary part of the number reversed in sign. So the complex conjugate of X plus IY is X minus IY. And that's also the complex conjugate of X minus, if you take theta as an angle, as in e to the I theta, and make the angle negative, you get the same result as if you made the real part, the imaginary part, change sign. In other words, if I have Z equals X, if I have Z equals cosine theta plus I sine theta, and I want conjugate of Z, sometimes you put a bar above Z to denote that, you would have cosine theta minus I sine theta. The negative, that the imaginary part, which is sine theta, gets reversed in sign. But that also is the same thing as if you took the e to the I theta and made a negative theta, because when you reverse the sign of the imaginary part, your angle goes in the opposite direction, but in the same fashion. So you can say that if Z equals e to the I theta equals cosine theta plus I sine theta, then Z, the conjugate of Z, or Z bar, is equal to e to the minus I theta equals cosine theta minus I sine theta. You just take the angle in the opposite direction. So the complex conjugate of e to the I theta is equal to the minus I theta. And the complex conjugate of x, of cosine x plus I sine x, let's do theta. The complex conjugate of cosine theta plus I sine theta is cosine theta minus I sine theta. Just take the imaginary part goes the other direction. It's reversed in sign. Yeah. And there's a lot of that's a brief rundown of higher math to me. I just thought I would do that. There's a lot of calculus involved in Fourier transforms, a lot of integration and stuff like that done to do Fourier transforms. It's a lot of integration, which is calculus, but yet it's also got complex numbers involved, and there's formula involved. So it takes calculus to the next level. Only it's really not calculus, but it uses calculus. And so there's that. Hope you guys enjoyed the video, and if there's anything else I want to say. There is one other thing, since I'm talking while I'm yapping, that I want to say. There's a thing called it's called what's it called? I gotta think of this. It's called it's not some constant. It's called let me think here. Structure. I think it's called the free structure constant. Free structure constant. I don't know. I'm not really sure. It's the fine structure constant. Yeah, that's it. Fine structure constant. It's a thing in physics, And it's approximately 1 over the number 137. So it's approximately one divided by 137, which is interesting. What it is it take if you take the charge of an electron, square it, and divide it by the speed of light times Planck's constant, you get this fine structure constant, which is approximately 1 over the number 137. And it turns out, and all the units of measurement in this equation all cancel out. They balance out to just a scalar. It's not even it's just a number. It's not even a measurable quantity that has any kind of unit of measurement. It's just a number. Real number, approximately 1 over 137. And it turns out that, and by the way, Planck's constant is a constant in quantum mechanics, and the speed of light is a constant in relativity, general relativity or special relativity. So the equation has quantum mechanics and relativity in it, both of them in it, and even the charged electron. And so it turns out if this constant were different, even by a very slight amount, either bigger or smaller than it is, this universe wouldn't exist. And if it did, it would be just a bunch of junk, and we wouldn't exist for sure. If the universe even would exist, it'd be all chaos, and we wouldn't exist because we can't exist in a chaotic universe. Life is high non-entropy, and you can't get non-entropy from chaos. So the only way we could exist as low entropy beings is if the universe had some structure and non-entropy in it. And it turns out if this number, the fine structure constant, were even slightly higher or lower, there would be chaos, completely chaos in the universe. I'm not sure of all the physics of why. I just believe it because I've studied it. I was not a physics major though, but I know a little bit about it. So anyway, I love you guys. Peace, love, and rock and roll.